Alright, so I'm Tyler White. I have the video assignment for section 11.8 power series. So the question is, for what value of x does this series converge? And so this is basically just asking for what interval of numbers does x converge. So to figure out these power series, we have to actually use the ratio test. So this is what the ratio test is. It takes the absolute value of this, and if it's less than 1, then we know that the series converges. So what we're going to do here is we're going to take the absolute value of this series. So that's basically what we do. So we put in n plus 1 wherever we see an n for the equation. And then we do the same thing, but we leave just it as n, and we divide the first one by just the other one that just says n on it. And clean this up a little bit. This looks a little confusing, but it's actually not too bad. We'll just take the reciprocal, and it makes it look a lot nicer. So when we take the reciprocal, we figure out that, all right, so x is actually a constant in this case. So we know that these two cancel out, and it leaves us just with a regular x minus 3 times n over n plus 1. So we know that just by looking at this, that if we take the derivative, that this will head to 1, and that this is just a constant, so this just gets left by itself. So the limit ends up being x minus 3 times 1, the absolute value x minus 3 times 1. So what we have to do now is we have to figure out the radii of convergence. And we know that the radii of convergence is absolute value x minus a is less than r. R is the radii of convergence. And if it is less than r, then it converges. So that's what we basically want to do. So we end up doing x minus 3 is less than 1 based off the ratio test. Because if it's less than 1, then it converges. And then to get rid of this absolute value, we know that for it to be less than r, for absolute value to be less than r, it also has to be greater than negative r. So this becomes negative 1 is less than x minus 3 is less than 1. So then to figure out the interval that x is less than 1, or that x converges, we basically have to take out this 3. We gotta get x by itself. So we just add 3 to every side here, and we get 2 is less than x less than 4. And this is the open interval for this series. But this is when it gets a little trickier. The power series can't just be left at this. We have to test these endpoints, because sometimes they do converge. They don't always just diverge at these endpoints. So we have to actually test it. So basically, for the first one, we have to just put in 2 into these series. So it's just 2 minus 3 to the n over n, and then it just becomes negative 1 to the n over n. And just by looking at this, we know that this converges based on an alternate series test. Just by looking at it, we know that this will become, the limit will end up equaling to 0, and that this decreases during this decreases over time. And then we know now that 2 does in fact converge. So now we test 4. And we just do the same thing here. And we do, so 4 minus 3, same thing, 1 to the n over n. And just by looking at this, we know that this diverges because of the p-series test, because this n is to the 1 power here. And when p is less than or equal to 1, it diverges. So we know that now 4 diverges. So the new interval of convergence here actually is square bracket 2, open bracket 4. And this would be the answer. It converges on 2, diverges on 4. All right, so that's what we got for question 1. And so now we got question 2, which is a little bit easier to figure out. There's not much work for question 2. It's more just a conceptual one. So the question is, true or false, if this power series converges for x equals 2, then it converges for x equals 1. And this ends up being true because if we know that if x equals 2 converges, that means that r must be greater than or equal to 2. So just by knowing how the power series works, we know that it converges over the interval of negative r to r. And since 1 is within negative 2 to 2, we know for a fact that it is within the range and that it also does converge. So that's basically it, guys. Hopefully that helps, and good luck on the test.